Welcome back to BioMinuteSA, where science meets clarity in just a few minutes. Today, we're tackling one of the most important topics in biochemistry, enzyme kinetics. By the end of this video, you'll understand the principles, equations, inhibition types, assays, and applications. Everything you need to master this foundation of biochemistry. Let's dive in. Enzyme kinetics is the study of how fast enzymes work, how reaction rates change with substrate concentration, enzyme concentration, inhibitors, and environmental conditions. Why does this matter? Because enzyme kinetics explains how life runs at the molecular level, and it's critical in medicine, biotechnology, and diagnostics. The most famous equation in enzyme kinetics is the Michaelis-Menten equation, V equals Vmax, S forward slash. Here, V is the reaction velocity, Vmax is the maximum rate, and Km is the substrate concentration at half Vmax. A low Km means high affinity for the substrate, while a high Km means low affinity. Scientists use graphs to analyze enzyme kinetics, including the Michaelis-Menten plot, which is a hyperbolic curve. The Lineweaver-Burk plot, a double reciprocal, gives a straight line, and other linear methods like Eadie-Hofstee and Hanes-Woolf plots also help us calculate Km and Vmax more accurately. Enzyme activity can be blocked by inhibitors. Competitive inhibition occurs when the inhibitor competes with the substrate for the active site. Non-competitive inhibition involves the inhibitor binding to a different site, decreasing Vmax while Km remains unchanged. Uncompetitive inhibition sees the inhibitor binding only to the enzyme-substrate complex, resulting in a decrease in both Km and Vmax. How do we measure enzyme activity? Through experimental assays like spectrophotometric assays, which track absorbance changes. Several factors influence enzyme activity: temperature, pH, substrate concentration, enzyme concentration, and cofactors and coenzymes. Enzyme kinetics isn't just theory. It's everywhere. In medicine for drug design, in biotechnology for optimizing enzymes, and in research for mapping metabolic pathways. So, enzyme kinetics is the backbone of biochemistry. Mastering Michaelis-Menten principles, inhibition types, graphical methods, assays, and applications will give you the tools to succeed in labs, research, and industry. Thanks for watching BioMinuteSA. If this helped you, don't forget to like, share, and subscribe for more science made simple. Drop a comment with your questions or the next topic you'd like us to cover. Until next time, stay curious, stay safe, and keep experimenting.